All right, good afternoon, everybody, or morning, or whenever you're watching this. This is Mr. Bear with Skill 23. So, last class we talked about exponential growth and exponential decay. So, let's remind ourselves of those words. So, we have growth. That happens when your growth factor, which, if we think about that equation, that's that b value, where the growth factor is greater than 1. Okay? And then we have decay when our b value, our growth factor, is between 0 and 1. To find the growth factor, what you're going to do is you're going to take 1 plus the rate of growth. So I'll think of that as 1 plus r. For the decay factor, you do 1 minus r. And both of those will be explained in a little more detail, or were explained a little bit more in the last video. So if you need to review, you may do so. So for instance, if it says your bank account's interest rate is 2%, your growth factor is 1 plus, 2% would be 0.02. So that makes that 1.02 when simplified. If a population decreases by 3%, so 0.03, we would do 1 minus 0.03, which would be 0.97. That would be our growth factor. Notice that that value is between 0 and 1. Some real life applications of using these. Anytime you take out a loan, anytime you do any kind of savings. I didn't actually put that on here. So savings accounts, credit cards, retirement accounts, which is really just a version of a savings account. Also mortgages, which are the things that you use to buy homes. In the past, we've talked about doing mortgage payments, but we're not going to get that far into it in the way that we're doing things this year. So we won't talk as much about mortgages this time. But just know that they use these ideas in mortgages as well. But the main ones we're going to look at are loans, credit cards, and savings, or at least in this lesson. So in all of these situations, we're going to need to know the compound interest formula. That's going to look like this. A equals P times the quantity 1 plus R divided by N to the NT. That's a lot of letters. So what does all that mean? So A is going to be total amount. So think of amount A. P is going to be what's called the principal. So that's either the loan amount or investment amount, depending on which scenario we're looking at. So if we're talking about a loan, that would be how much you want to borrow. So if that car is $10,000, you're borrowing $10,000. If you are making an investment, that would be like a savings account. I'm going to put $1,000 into my savings account, and then I'm going to watch it grow. R is going to be your rate, and we have to write that as a decimal. So that's why in those examples with the percentages a moment ago, I converted those to decimals. Then N is going to be the number of compounds. And that will be per year. Oh, that looks terrible. Number of compounds per year. And T is going to be time in years. All right, so let's go ahead and look at an application of this. So let's see. You take out a loan for a new car and it's a list price of $20,000. That's going to be your P value. You borrow money at an annual percentage rate. You'll see that is APR for short, of 5%. So that would be a rate of 0.05. Remember, we just slide that decimal to the left 2 places. And we're going to compound monthly, which means there will be 12 compound periods. And our T value, oh, I'm mad that that went to a new line. Our T value is going to be how many years we have it. So it looks like it's a 5-year loan, so T is 5. So the first question is, how much money will you pay in total for that shouldn't say the new home, that should say the new car. Wow. Okay, so looking at this, let's go ahead and apply our formula. So a reminder to us, the formula is right here. A equals our principal, so our P, which in this case is 20,000, times 1 plus our rate, which is 0.05, divided by n, which is number of compounds, so that was 12, raised to the power of n times t, so 12 times 5. All right. Now we're going to do a little bit of simplification. I'm going to use my calculator. I take 0.05 divided by 12 and add 1 to that. And my calculator gives me a really long decimal, 1.004166667. I'm sure that was rounded. 12 times 5 is 60, but what I'm going to do is I'm going to go ahead with what's on my calculator. I'm going to go ahead and raise that to the 60th power and then multiply that by 20,000. And that gives me 25667.17 when rounded to the nearest cent. All right, so that's how much I'll pay in total. So the car itself was $20,000, so you're paying over $5,667 as interest. Okay. Now, also, I'm a little frustrated because I wanted this part B to. I'm going to do that up here. Okay. If I want to figure out my monthly payment, what I'm going to do, so monthly payment, we know how much we're going to pay total, so $25,667.17. I'm going to divide by how many months that I'm paying on the loan. So the number of months, if they don't tell you directly, then you take 12 times the number of years. In this case, 12 times 5 is 60. So I'm putting that up here to remind you of that. And so now I'm going to take this value and divide it by 60, and I'm going to get 427.79 when rounded. That sounds about right for a brand new car. Of course, the interest rate is 5%, so that might be a little on the high end. You can always negotiate smaller rates, or you can ask to pay over more time, depending on what your credit rating is. All right, but that's how we calculate monthly payment based on the total amount. Okay, so now let's talk about credit cards. One fact of adult life is that many people use credit cards for those unexpected expenses. The way that credit cards work is that you are borrowing money with the promise that you'll pay back what you borrowed through monthly payments. When you borrow money using a credit card, the payments you make are compounded monthly. So that is a given. And I can't seem to draw right now. Why can't I draw? There we go. Sorry. So below is an illustration of how credit card payments are determined. So let's say that you really want to purchase a new 4K TV for $1,000 and you charge the cost to your Visa credit card. Your credit card has an APR of 13%. So that means over the course of the year, your interest rate is 13%. Your credit card statement comes in and it says that your minimum payment is only $15. So I want to show you kind of a pitfall that sometimes people make when they do credit cards. Okay. So you'll notice the first few lines are done. So to figure out your balance each month, you have your payment, you have your interest on whatever this balance is, and the way you figure out your interest is equal to principal times rate times time. This is simple interest. The way we figure out that time, since it's a monthly payment, that's why you see this 1/12 here. To figure out your principal, what you're going to do is you're going to take your previous balance, you're going to subtract off your payment, add your interest, and that's going to tell you your new balance. Now, sometimes people will do, they take their payment minus their interest, and then they'll subtract that off of their balance. So it just depends on how you want to go about this. I think I'm going to model it this way on here because that's how I have it written out. But when you look at the classwork, you might see that this last column is going to look a little different. So let's see what we got going on here. So we start with a balance of $1,000. We made our $15 payment, but we have to figure out our interest amount. So I equals PRT. So we take our $1,000, multiply it by 0.13, which is the APR. But that's for the whole year, so we have to multiply by our time, which is 1/12. When you multiply all that out, you get $10.83. So that's the interest charged on this $1,000. So you have to, the way you would think about it is you have your balance, you subtract off what you made as your payment, but then that interest charge is going to go back into your principal, okay? So now we have $995.83. Now what we're going to do is that balance carries over to the next month, and we start the process the same. We know we're going to make a $15 payment, so what we're going to have here is we take that balance, multiply it by 0.13 times 1/12, and you'll notice this time the interest is a little bit smaller, and that's because our balance was a little bit smaller. So $10.79. So we take our balance, subtract the payment, add the interest. Now we're at $991.62. So that carries over to the next month. And now what we're going to do is the same process. So we're going to keep on going. And for some reason I can't draw. Sorry about that. Let me explain again. I had to pause the video here. So we have our amount, our balance, okay? And we're going to do the same process. Notice this time our interest on the balance is a little bit lower because our balance is a little bit lower. By the way, this also assumes that you are not charging new things to your card. So keep that in mind. What's going to happen is you're going to keep following this process here. So I'm going to carry this balance over, 987.36. I'd carry this balance over. We're going to pay another $15 on it. To figure out the interest, I'm not going to write all that out anymore. I'm just going to take 987.36, multiply it by 0.13. That's going to give me $10.70. So I'm going to take my balance, 987.36. I'm going to subtract off my payment. I'm going to add on to that my interest, and that gives me 983.06. Okay, so that carries over to the next month. And you kind of see what's happening here. So let me illustrate something real quick. After basically 4 months of making payments, so we've made 4 payments at this point, basically, you'll notice that you've paid $15, $30, $45, $60, and your balance is $983. Your balance is a little less than $17 lower than what it was when you started, even though you've paid $60 of payments. So what the moral of the story is just because you see that minimum payment of $15, you should always aim to pay more than the minimum, okay? In fact, you should honestly aim to pay off your credit card. Now, I know on a $1,000 purchase that may be hard to do, but just know that if you were to pay off the balance every month, you don't have all this interest building up, and therefore you basically are using your credit card like a debit card in a way. One of the reasons people get credit cards, though, is because they don't have to pay it all off at once. But if you pay more than the minimum payment, then you'll make more of an impact on your balance over time by making those larger payments, okay? So I'm not going to finish out this chart here. We'll talk more about this in class, but it's a good investigation if we had more time for it. But just basically what you would notice about the payments is even though you're making all these $15 payments every month, your balance isn't decreasing by that much with a minimum payment only as your payment. All right, last thing that I'm going to talk about is savings. And so I want to talk a little bit about what that looks like. Formula for savings is just like it was for loans. It is going to be identical formula. We want to see how $1,000 grows over various lengths of time. So I'm going to talk about how interest rate and time affects what your savings account would look like. So we're going to assume $1,000 in each situation. So A equals 1,000 times 1 plus, my rate is 5.5%, so 0.055, compounding quarterly, so N equals 4, to the power of 4 times RT, which is 10. Okay? The way I'm going to do this on my calculator is I'm going to start with 0.055 divided by 4. So I'm working inside the parentheses, and I'm doing my division inside there first because I have multiple operations under there. I take that value and I add 1 to it. That gives me like 1.01375. Exponent is 40. So now I'm just going to take my 1.01375, raise it to the 40th power, and multiply that by 1,000, and I'll have $1,726.77 in my account after 10 years in this scenario. So let's see what happens if we have the same rate, but we double our amount of time that's in here. So what's going to happen to this account? So everything is going to be the same. The only thing that will change is the exponent. It'll be 4 times 20. So we'll end up with this. And so I'm going to go ahead and calculate that. And just by that alone, oh, it makes this go $2,981.74. Ooh, that's nice. Okay. So putting that money in there for double the time is going to do wonders for the account. Situation 3, same thing, but this time I am improving my interest rate. So it's 7.5%. So I'm going to go ahead and do that. Take 0.075 divided by 4, add 1. That gives me 1.01875 to the 40th. So compare this to the answer we got in situation 1. And that gave us, $2,102.35. So with a higher interest rate, we got a few hundred more dollars over that 10-year period. And now let's compare that to the length of time. So if I do situation 4, we're going to compare this to situation 3, but maybe also situation 2. It's the same exact setup as we had here, except instead of 4 times 10, it'll be 4 times 20. So I'm going to do 1.01875 raised to the 80th power, and I'm going to multiply that by 1,000. And that amount ends up being $4,419.87. So that's magnificent. That means that we are going to have over 4 times the amount of money that we had started with if we have a 7.5% interest rate and we compound quarterly for 20 years. Okay, so the moral of the story here is look for a high interest rate and keep the money in your account as long as possible. This is the great thing about savings. Okay, so thinking about retirement and such, you always want to make sure you get a higher interest rate, but keep your money in there as long as possible. That's how the money grows faster and faster. If you take money out, it just will reduce your amount that you will end up compounding over time.